If you call the same C++ template function with different types and it has a static variable inside, what do you think happens? Do all types share the same static value, or does each type get its own? In this example here, we have counter, which is a function template. Inside, we define a static int of total calls. It increases every time the function runs. But in main, we call the function with ints, doubles, and chars in this specific order here. Now, take a minute to think about what will happen when we run this code. Okay, now that I've given you some time to think about it, let's go ahead and run it and see what happens. And as you can see, we first call it with the double, we get 1 for that, then the int 1, the char 1, and then when we call the int the second time we get 2, double the second time we get 2, and double the third time we get 3, right? So let's think about this for a second. A static variable inside a function is initialized once and it keeps its value across all calls, and it's stored in the static storage area, specifically the data segment of the program's layout and not on the stack. In C++, when you use a function template, the compiler creates a separate version of the function for each unique type you call it with. So counter with the int, counter with the double, and counter with the char are all different functions at the binary level. This means that the static count inside each function is also unique to that type. It doesn't matter what the code looks shared, the state isn't.